thought I would put together a screencast for balancing using the 1/2 trick. Thought it might be helpful. So let's go ahead and do a couple of examples here. Let's start with this one. I've got nitrogen reacting with oxygen and water to produce nitric acid. This combination reaction has some nitrogen there, and it's got some oxygen, and it's got some hydrogen. So at this point we can go ahead and count up our atoms on each side. I've got 2 nitrogens on the reactant side, 1 nitrogen on the product side. I've got 3 oxygens, 2 here, 1 there. On the reactant side I've got 3 oxygens on the product side, and then I've got 2 hydrogens on the reactant side, 1 hydrogen on the product side. So my oxygens are balanced, my hydrogen and my nitrogen are out of balance. What I'll do is I'll go ahead and put a 2, because 2 times 1 gives me 2 hydrogens. So I'll put a 2 out in front of there, and that will change pretty much everything on the product side. So now I've got 2 times 1 gives me 2 hydrogens. 2 times 1 gives me 2 nitrogens. 2 times 3 gives me 6 oxygens. So everything's in balance except for the oxygen. So what I'll do is I've got oxygen in 2 places here. So pretty much I've got 6 oxygens on this side, and I've got 1 oxygen for my hydrogen, and I've got 2 hydrogens, excuse me, 1 oxygen for my water, and 2 oxygens from this oxygen molecule here. Ideally, I'd like to put something in front of this because it won't change won't change anything else. So essentially, I want to multiply something by 2 plus 1 equals 6. Kind of turned it into an algebra problem. You don't have to get this elaborate, but I'm just trying to show you this visually. So what I would do is I'd subtract this 1 over from each side, and I would wind up with what times 2 is going to be equal to 5. And that's really what I've said in class. You know, I'm looking at this, I know I've got 1 here, and I want to multiply this by something in order to get to 5. So what times 2 gives me 5? Well, that is 2.5. So what I would do is I'd go ahead and put a 2.5 out in front of this oxygen. Get rid of this stuff here. Well, it's balanced. I mean, right now this is balanced, and I can show you that. Let's go ahead. That would change my oxygens. And what I would have is I would have 2.5 times 2 is 5, plus another one is 6. So this is balanced. The problem is that I can't leave this as a fraction. And just like we did with molecular and empirical formulas, what I would do is I would multiply all these coefficients by 2 in order to get rid of that 1/2. So I'd multiply all my coefficients by 2 in order to get rid of that 1/2. So I'd go ahead and distribute this 2 to everything inside of the parentheses, and it would be 2 times 1, which would give me 2 nitrogens, plus 2 times 2.5 would give me 5 oxygens, plus 2 times 1 would give me 2 waters, and then 2 times 2 would give me 4 nitric acids. And I would have a final balanced equation. I double check this really quick. I have 4 nitrogens over here. 4 times 1 gives me 4 nitrogens there. I've got 10 plus another 2 is 12 oxygens over on the reactant side. 3 times 4 gives me 12 oxygens over on the product side. And then 2 times 2 gives me 4 hydrogens. 4 times 1 gives me 4 hydrogens over here. And this is balanced. Now it's balanced with whole numbers and no fractions. So that's really the way we want these things. Lowest whole number ratios, just like the empirical and molecular formulas. Lowest whole number coefficients in order to balance the equation. Let's try one more of these, and then we'll go ahead and wrap it up. So I've got a combustion reaction here. The reason I can tell it's combustion is because I've got an oxygen here, and it produces just carbon dioxide and water. So let me go ahead and list my atoms. I've got carbon, I've got hydrogen, and I've got oxygen. The 1/2 trick, if you notice, comes in handy when you're trying to balance stuff with the Hunkelbriefs in it, specifically oxygen. That's the most common one. Again, I've got a Hunkelbrief oxygen here. So let's go ahead and start counting things up. I've got 2 carbons on the reactant side, 1 on the product side. I've got 6 hydrogens on the reactant side. I've got 2 on the product side. And then I've got 2 oxygens on the reactant side, and I've got 3, 2 from here, 1 from here, oxygens on the product side. So I want to go ahead and start balancing this up, and what I might do is throw a 2 in front of my carbon dioxide, because what times 1 gives me 2, and that will change my carbon and my oxygen on the product side. So now I've got 2 carbons, and then 2 times 2 gives me 4 plus another 1, and 5 oxygens. We always save oxygen for last. Hopefully this will balance out, but I can already tell you it doesn't. Otherwise, I wouldn't be showing you the 1/2 trick with it. So let's see here. The next thing I'm going to do is balance up my hydrogens. I've got 6 over here, 2 over here. What times 2 gives me 6? Well, the answer to that is a 3, so I'm going to put a 3. Let's keep the colors the same. I'm going to put a 3 out in front of here, so that's going to change my hydrogen and my oxygen again. So I've got, let's see here, 3 times 2 is 6 hydrogens on the product side now, so that's balanced. And my oxygens, I've got 2 times 2 is 4, plus another 3, that's 7 oxygens. I've only got oxygen in one place over here, so this makes life a little easier. This is where I want to put something. If I put 3, that's going to be too small, because that'll give me 6. If I put 4 there, that's going to be too large, because that'll give me 8. So 3 won't work, and 4 won't work. What is halfway between 3 and 4? That would work, and that is 3.5. So what I'm going to do is I'm going to put 3.5 out in front of my oxygen. Again, same trouble I had before. That is a fraction. I cannot live with fractional coefficients in a balanced equation. So what I'm going to do is I'm going to balance this out by multiplying everything by 2. So what I wind up with is 2 times 1. I'm multiplying the coefficient out in front by this multiplier here. And I wind up with 2C2H6 plus 2 times 3.5 gives me 7O2 to produce 2 times 2 is 4 carbon dioxide, and 2 times 3 is 6 waters. Let me just double check to make sure it's balanced. As far as carbon goes, I got 2 times 2 is 4. I've got 4 over on this side. 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. 7 times 2 is 14 oxygens on this side. And I've got 2 times 4 is 8 oxygens, plus another 6 oxygens is equal to 14 oxygens. And we are balanced at this spot right here. Yeah, the 1/2 trick comes in handy when you've got the Honkelbriefs, stuff like oxygen, nitrogen, iodine, fluorine, hydrogen, chlorine, 1, 2, 3, 4, 5, 6. What am I missing? Honkelbrief. Oh, and bromine. I know they're not in order, but those are the Honkelbriefs.